Hey everyone, we are going to talk about derivatives of inverse functions. So we did a little bit of investigating in class and kind of started to talk about it, but to have it officially down in your notes and to go through some examples, you're going to go through this video. So there are two very important things about the derivatives of inverse functions. The first thing that we need to remember is that the derivative of an inverse function is the reciprocal of the derivative of the original function. The derivative of an inverse function is the reciprocal of the derivative of the original function. That's a lot of ofs, right? So let's look at what this notation would actually look like. So f inverse, and we want the derivative. So the derivative of the inverse is equal to the reciprocal of the derivative of the original. So f inverse prime is equal to 1 over f prime. So this is our derivative of the inverse. This is the derivative of the original, and then reciprocal means the flip of it. Okay? The other really important piece that we need to talk about when it comes to derivatives of inverses is that we need to remember that the input of the inverse is the output of the original function. And I'm going to write and vice versa. Vice versa. So the input of the inverse is the output of the original, and the output of the inverse is the input of the original. That's what vice versa means. Okay, if we switch input and output, it would still work. Okay, so that's going to be super important as well. So let's look at what an example of this is going to look like. F is the function defined by f of x equals x cubed plus 7x plus 2. G of x is f inverse of x, and f of 1 equals 10. What is the value of g prime of 10? So there's a couple things we need to look at here. So first of all, let's look at the fact that g of x is equal to f inverse of x, which means g of x is our inverse function. Okay? And we also know that when we take g prime then, so g prime, the derivative of g, is going to be equal to f inverse prime, so the derivative of the inverse, which we just said is equal to the reciprocal of the derivative of the original. So when we look at this portion right here, g prime and then f inverse prime, that's our inverse part. All right, and then this part over here, this f prime, that's part of our original. Okay. Now we're looking for g prime of 10. Well, g is our inverse function. So this 10 right here, that must be the input of the inverse. Whoops, let me move it over a little bit. All right, so 10 is the input of the inverse. Now, when I do these problems, I always write 2 coordinate points. All right, so I'm going to write a coordinate point for the inverse, And I'm going to write a coordinate point for the original. All right, well, I know that this 10 is the input for my inverse, so that's going to be right there. And then I know that my original point, I was given f1 equals 10, so my original input is 1, and my output is 10. All right, so I always have these two coordinate points like this. So next, let's look at what actually happens here when we start to plug things in. So g prime of 10 is going to equal the derivative of the inverse of 10. So that's all part of my inverse. And then that's going to equal the reciprocal of the derivative of the original function. So f prime of not 1, but 10. I'm sorry, not 10, but 1. Whew. All right. F inverse prime of 10 means we have to look at what was the input in our original function. So that's where this 1 is coming from. This was the input of the inverse. This needs to be the input of the original. All right, I know it's a little confusing. But what that means then is I need f prime of 1 so that I can figure out what the reciprocal of that is. So if we look at our original function, we actually had f of x equals x to the third plus 7x plus 2. So f prime of x is going to equal 3x squared plus 7, which means if I want to find f prime of 1, I'm going to get 3 times 1 squared plus 7, and that just gives me 10, which means g prime of 10 is going to equal 1 over 10. That is the reciprocal of the derivative of the original function. Okay? I know it's confusing. We're going to go through another example right now, and we're going to do tons of practice in class because I know it can be confusing. So let's take a look at what we have here. F is the function. We've got f of x equals 7x to the third plus the quantity of natural log x cubed. And we know that, this should be a g of x. Sorry, let's make that g of x equals f inverse of x. F of 1 is 7. What is the value of g prime of 7? So we need to look at the fact that g of x is equal to f inverse of x. So this is our inverse part. All right, and f of x, this function here, this is our original. Okay. Then when we're looking for g prime of 7. So 7 is the input of the inverse. So when I write my two coordinate points, I have inverse, I know is 7 and something. And in my original, I know that I was given the point 1, 7. Okay. I know that if I want to take the derivative of g prime is going to equal the derivative of the inverse, which we know is equal to the reciprocal of the derivative of the original. Okay, so we're doing the same thing we did in the problem above. Now let's look at this specific case. So g prime of 7 is going to equal the derivative of the inverse at 7, which is going to equal 1 over, we know that we need the derivative of the original function, but that means we need then the input of the original function, which in this case was 1, because that is our value right here. All right, and if you notice, f inverse prime of 7 is equal to 1 over f prime of 1, and 1, 7 is actually our original coordinate point. All right, because this portion here is the input of the inverse, which means it's the output of the original. Okay, I know it's a lot of inputs and outputs. Hopefully you guys are still with me. Okay, so that means then we're going to need the derivative of the original function so that we can find f prime of 1. So f prime of x is going to equal, we can drop the 3 and subtract 1, so 21x squared, plus we're going to need some chain rule here. Take the derivative of the outside, which would be 3 natural log of x squared, and then multiply by the derivative of the natural log of x, which is 1 over x. And we want to figure out what is f prime of 1. So we would get 21 plus 3. The natural log of 1 is actually just 0, so 0 squared, and then times 1 over 1. But this whole portion actually turns into a 0, so it doesn't really matter. F prime of 1 is equal to 21. All right, so now we know then that g prime of 7 must be 1 over 21. All right, I know that can be a little confusing, but like I said, we are going to do tons of practice in class and be able to talk through any questions that you guys have. All right, I'll see you later. Bye.